The Juno spacecraft conducts measurements of oxygen production on Europa, one of Jupiter's moons. Greetings and salutations to everyone. Today we will delve into an intriguing topic related to NASA's Juno spacecraft and its remarkable discovery on Jupiter's moon, Europa. Recent observations have revealed substantial amounts of charged molecular oxygen and hydrogen in Europa's atmosphere. This groundbreaking finding carries significant implications for the potential habitability of Europa. It is believed that the oxygen produced in the ice could potentially make its way to the moon's subsurface ocean, serving as a potential source of metabolic energy. This study marks the first ever direct measurement of water components present in Europa's atmosphere, providing us with a narrower range that could support habitability. These new measurements contribute immensely to our understanding of Europa and its unique environment, paving the way for more precise and advanced models. Without any further delay, let us begin our discussion. Dr. Scott Bolton, the co-author of the study and Juno principal investigator from SRRI, emphasized the significant impact of these discoveries on the potential habitability of Europa. With the first ever direct measurement of water components in Europa's atmosphere, this study establishes a precise range that holds promise for supporting habitable conditions. During its journey in 2022, Juno successfully conducted a close encounter with Europa, reaching a proximity of 352 kilometers to the moon. On board Juno, the Jovian Auroral Distributions Experiment, JADE, developed by SRRI, detected notable quantities of charged molecular oxygen and hydrogen that had been discharged from the atmosphere. Dr. Robert Ebert, a co-author and staff scientist at SRRI, expressed that the recent in situ measurements have provided conclusive evidence of hydrogen and oxygen detection, thus solidifying the understanding that Europa's atmosphere consists mainly of hydrogen and oxygen molecules. Water ice on the surface of Europa is believed to be the origin of these molecules. Due to the intense radiation from Jupiter, the molecular bonds of H2O are broken, resulting in the release of oxygen and hydrogen. The heavier oxygen molecules tend to stay closer to the surface or in the near-surface atmosphere, while the lighter hydrogen molecules mostly escape into the atmosphere and beyond. Some of the oxygen produced in the ice is either lost from the atmosphere or trapped in the surface. Oxygen that remains in Europa's ice has the potential to migrate to its subsurface ocean, potentially serving as a source of metabolic energy. According to Dr. Jamie Salai, the lead author of the study and a research scholar at Princeton University, Europa's ice shell serves as a shield against radiation and also generates oxygen within the ice. In this sense, the ice shell can be likened to Europa's respiratory system, potentially providing a source of oxygen for the underlying ocean. The study has placed specific limits on the current oxygen production rate on Europa, estimating it to be approximately 12 kilograms per second. This finding contradicts previous estimates, which range from a few kg per second to over 1,000 kilograms per second, and unequivocally confirms that oxygen is continuously being produced on the surface of Europa, albeit at a lower rate than initially anticipated. Dr. Frederick Allegrini, a staff scientist at SRRI and co-author, explained that JADE was specifically created to analyze the charged particles responsible for Jupiter's captivating auroras. While the Juno mission did not initially include flybys of Europa, JADE was still able to function exceptionally well despite not being designed for the intense radiation environment of Europa. This instrument was originally intended to operate in a high radiation setting, but it exceeded expectations and delivered outstanding performance. By providing fresh data, the latest measurements enhance our comprehension of Europa and its surroundings, paving the way for more accurate and advanced models. For instance, the study's updated calculation of oxygen production on Europa's surface has the potential to guide future investigations into its subsurface ocean and the possibility of supporting life. These observations, which mark the first assessment of charged particle composition in Europa's vicinity, offer a valuable new perspective on the Moon's intricate relationship with its environment. According to Ebert, Europa holds a captivating allure due to the certainty among scientists that it harbors a liquid ocean within its core. The presence of water is crucial for the potential sustenance of life and can manifest in diverse forms on celestial bodies. Considering these factors, Europa emerges as a prime candidate for the exploration of water within our solar system. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.